stamp example in the last two videos works for many types of problems. Proof by induction is useful when trying to prove statements about all natural numbers or all natural numbers greater than some fixed first case, like 28 in the stamp example, and in some other situations too. In particular, induction should be used when there is some way to go from one case to the next, when you can see how to always do one more. This is a really big idea. Thinking about a problem inductively can give new insight into the problem. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below, and make sure to click on that subscribe button. All right, to really understand the stamp problem, you should think about how any amount of postage greater than 28 cents can be made. This is non-inductive reasoning. And also how the ways in which postage can be made changes as the amount increases, which is inductive reasoning. When you are asked to provide a proof by induction, you are being asked to think about the problem dynamically. How does increasing n change the problem? But there is another side to proofs by induction as well. In mathematics, it is not enough to understand a problem. You must also be able to communicate the problem to others. Like any discipline, mathematics has standard language and style, allowing mathematicians to share their ideas efficiently. Proofs by induction have a certain formal style, and being able to write in the style is important. It allows us to keep our ideas organized and might even help us with formulating a proof. In the next several videos, we'll discuss mathematical induction in much more detail because this approach to proving certain statements can be very challenging, but we'll do many examples to make sure we develop a strong understanding of mathematical induction. I'll see you all in the next lecture.